Good day, everyone. Let us try to solve this algebra problem. Now, in this problem, we're going to simplify a very large radical number. We're going to get the square root of a number consisting of 2002 fours, followed by 2001 eighths, and a one digit of 9. Now, the first thing that we're going to do to solve this is we're going to let the number inside the radical symbol be equal to x. Now, before we continue, let us recall the concept of expanded notation of a number. Now, when we write numbers in expanded notation, let's say, for example, we have 524, we will be writing this as 500 plus 20 plus 4. So what we did is we separated the digits according to their place values. So 524, like I said, is now 500 plus 20 plus 4. Now, since 500 is on the hundreds, 20 is on the tens, and 4 is in the ones, this will be 5 times 10 squared plus 2 times 10 to the 1 plus 4 times 10 to the 0. Now, notice that we multiply each of the digits in the place value by a power of 10. This is because our numeration system is always base 10. So that's why we did it this way. Now, following the concept of expanded notation, the number here, this one, can be written as 444, then you have trailing zeros, plus you have 888, then you have 10 plus 9. Now, again, in this case, we separated the number according to its digits, and we assume that the group of successive fours will constitute the highest place value. So, just like in our example, 5 is in the hundreds place, so we put two trailing zeros after it. Now here, there are 2002 fours as indicated in the given. So, as a consequence, there will be 2002 trailing zeros as well. Now, after a series of eights, we got a 9. Now, the 9 here is the last digit. So, if we apply the same concept that we had in expanded notation, the group consisting the 2001 eighths should have one trailing zero. So, let us go back to the group of fours and the trailing zeros that it has. Now, we work this out first. Now, we write them in expanded form. So, we have 4 times 10 to the 2001 plus 4 times 10 raised to the power of 2000 plus so on and so forth until 4 times 10 to the 0 times 10 raised to the power of 2002. Now, the 10 raised to the power of 2002 at the end here represents the place value multiplier. Now, notice also that the highest exponent of 10 in the expansion of the series of fours is 1 less than the number of fours. This is because, just like the expanded notation of 524, though 500 has 3 digits, it has 2 trailing zeros, making the exponent of 10 in the expansion 2. So generally, the highest exponent of the digit in the expansion group is 2001 right here. Now, let's consider the 8th group, that one. Now, we work this out. We have this one here. And then apply the same process we did with the first block. We have this one here. So it's just the same thing with the fours. This is what we did with the eights. Now, let us look at the expansion series of 4. Now, we factor out 4 to get this expression. Now, these tens here inside the parenthesis forms a geometric series. Now, to get the sum, we use the formula S sub n is equals to A sub 1 times quantity 1 minus r raised to the power of n all over 1 minus r. Now, substituting the values in the formula, we have this one here. And simplifying, we have 10 raised to the power of 2002 minus 1 times 9. Then, after that, we put the 4 and the 10 raised to the power of 2002, we have now this one. Now, finally, we simplify this further. We have now this part here. We have 4 times 10 raised to the power of 4004 minus 4 times 10 raised to the power of 2002 all over 9. Now, let us work out the expansion of 8 this time. So first, we have that one. And then again, these tens here forms a geometric series. So we have this one here. And then this will simplify into 10 raised to the power of 2001 minus 1 all over 9. So the expansion for 8 now will be this one. And simplifying, we will be able to get 8 times 10 raised to the power of 2002 minus 8 times 10 raised to the power of 1 all over 9. Now, after dissecting the number into expansion groups and simplifying, the number can now be written as this one. This is for the 4s, and this is for the 8s, and you have the 9 there remaining. Now, getting the LCD, we get this part here. And combining like terms, we now get this. And simplifying further, we finally get 4 times 10 raised to the power of 4004 plus 4 times 10 raised to the power of 2002 plus 1 all over 9. So that means now that the number is transformed to this one here. Now this time, notice that 4 times 10 raised to the power of 4004 is just equal to 2 times 10 raised to the power of 2002 quantity squared. And obviously, 1 is just 1 squared. Now, we multiply 2 times 10 raised to the power of 2002 squared and 1 squared, we get the middle term that is 4 times 10 raised to the power of 2002. So this means the expansion 4 times 10 raised to the power of 4004 plus 4 times 10 raised to the power of 2002 plus 1 all over 9 is a perfect square trinomial that can be written in the form of 2 times 10 raised to the power of 2002 quantity squared plus 2 times 2 times 10 raised to the power of 2002 plus 1 all over 9. Now, we write it as a square of a binomial. We have 2 times 10 raised to the power of 2002 plus 1 quantity squared all over 9. Now, we take the square root. So, the square root of this one, since it has an exponent of 2, and then you have 9 here, which is a perfect square, will just be equal to 2 times 10 raised to the power of 2002 plus 1 all over 3. And now we see that we have this one here. So you have 2 times 10 raised to the power of 2002 plus 1 all over 3. There are 2002 zeros, or the place value is now at the 2002nd power of 10. So that could be written as 2 followed by 2001 zeros plus 1 over 3. So this will be 2, 2000 zeros, and 1 all over 3. Now let us divide it by 3. But before we divide it by 3, we have to have a pattern first. And as you can see, if we have 201 divided by 3, that gives us 67. 201 divided by 3, that gives us 667. And 20,001 divided by 3 is equals to 6,667. So from here, we can conclude that the number of zeros in the dividend is just equal to the number of 6 in the quotient. So that means since this has 2001 zeros, then we have an answer containing of 2016 followed by the last digit, which is 7. So therefore, this number, when we simplify by extracting the square root, is just equal to a number containing 2016 and a ones digit of 7. And the problem is solved, and this is now our answer. So that's it for this video. Please don't forget to like and subscribe to our channel for more challenging algebra problems. Thank you so much. Enjoy learning.